All right, we're on to our last type of factoring. So we have learned how to greatest common factor, how to group, how to factor trinomials using the AC method, as well as, kind of drawing your two brackets when the leading coefficient is a 1. Also, if they're perfect square trinomials. We've learned difference of squares, and now our last one here is called a sum and difference of cubes. Just going to preface this with it's not my favorite. Although I've come to love it because I've got this little acronym that we get to sing, but whatever. So again, this is going to be the answer. Weird, hey? It's a binomial times a trinomial. Now let's look to see what the question's going to be. So I'm going to multiply this out. So 2x times 4x squared is 8x cubed. 2x times 6x is 12x squared. 2x times 9 is 18x. Now I'm going to multiply the negative 3 through. So I'm going to do it vertically. So I'm going to get negative 12x squared. Interesting. 3 times 6, negative 3 times 6 is negative 18x. Interesting. Negative 3 times 7 is negative 27. I end up with 8x cubed minus 27. A sum or difference of two perfect cubes. This is very similar to a difference of squares. So it's got to be a binomial, but the difference is that it can be a sum or a difference. So it can be a plus or a minus sign between the two terms. But then the two terms have to be perfect cubes. So perfect cubes I'm not as familiar with as I am with my perfect squares. So again, let's go through and list them. You'll notice it only goes 1 to 5. So 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. And those are the only ones that you're expected to recognize. Okay, so these 5 numbers are perfect cubes. I will point out to you, though, that this one and this one are tricky because they're perfect cubes and perfect squares. So there has to be another clue in the question, whether you're talking about a difference of squares or a sum or difference of cubes. And that's usually going to be the exponent. So let's look at the power. So if I have x all cubed, I get x cubed. X squared all cubed, I get x to the 6. And hopefully everybody knows I'm using the power rule, right? So when you have a power raised to an exponent, you multiply, okay? And then I get x to the 9 and I get x to the 12. What do you notice about all of these exponents? When we were looking at difference of squares, they were all divisible by 2. For this one, you should notice that the exponent is divisible by 3. Okay, that will make it a perfect cube power. So which of these are sums or differences of cubes? Well, the first thing is there has to be 2 terms. Good. Plus or minus sign. Good. So really what we're doing is looking if they're perfect cubes. So 125 x cubed, all good. 8, all good. Why to the 5? No. Okay. What about the next one? 64, yep. X to the 6, yep. 1, yep. Okay, this guy's good. This one, 8, yes. Plus, yes. 1x cubed, all good. Lastly, 4, nope. And b, nope. So these two would be a sum or difference of cubes. Now let's talk about how to factor it. This is the fun part. So on your formula sheet, there is a formula for factoring a sum or difference of cubes, which I hate using, but it's there. So chapter 5. This is the formula. So what you're supposed to look at is notice that in here I have a cubed and b cubed, and here I have an a and a b. And then in the second bracket, I have a squared, ab, and b squared. What that means is that I took the cubed root of each term, and then I squared it, I multiply them together, and then I square that term. And that's how you factor it. It's kind of weird. Okay, so here's the process. To factor a sum or difference of cubes, you take the cubed root of each term. So the cubed root of 8x cubed would be 2x. Cubed root of 27 would be 3. Then you draw 2 brackets, first one fitting a binomial, second one fitting a trinomial, and you put those cubed roots into the first bracket. Then, here's where the fun begins, okay? I call it sending a text message to the second bracket. If you remember, there used to be like commercials where it say SMS charges may apply. What that means is we're going to square the first term and write it first. We're going to multiply the two terms together, write that second, and then we're going to square the last term and write it last. So we would end up in our bracket with 2x and a 3, and then a 4x squared, a 6x, and a 9. And then the last thing we're going to do is our signs. So in the formula, you'll notice that a difference of cubes goes minus plus plus, and a sum of cubes goes plus minus plus. The way I remember this is SOAP. The first sign is always the same as the question. So since this is a difference of cubes, you get a minus in the first bracket. So this is the same. Then the second sign is always opposite what this sign was. And then your last sign always has to be positive. So SOAP, same, opposite, always positive. So let's try a few. So I did these first two questions the exact same, just one's a sum of cubes and one's a difference of cubes because I wanted to show you really the difference. So step number 1, greatest common factor, there isn't one. So we're going to draw a bracket that fits a binomial, and then I open my second bracket and I often don't close it just so that I make sure I have enough room. And then we factor. So the cubed root of x cubed is x. The cubed root of 8 is 2. The cubed root of x cubed is x. The cubed root of 8 is 2. Nothing different. Into the second bracket, we're going to square the first term. So x squared. Then we're going to multiply these two numbers together. And then we're going to square this last term. Doesn't matter if the second one's different. So square it, multiply, square it. Some people like this step where they show the multiplying and then they show the squaring. I like to just keep things simple, so I show as little work as possible. So I just multiply it and square it as I go. And then we do the signs. Same, opposite, always positive. Same, opposite, always positive. And that's it. That's the process. So 2 more questions. This one, is it a difference of cubes? Yes. Is there a greatest common factor? Ooh, that's a good question. 27 divided by 3 is 9. 64 divided by 3, nope. I almost thought there was. Okay, there's no greatest common factor, so let's just factor this as a difference of cubes. So I'm going to draw a binomial bracket, and then I'm going to open a trinomial bracket. Take the cubed root of the first term. So the cubed root of 27 is 3. The cubed root of w cubed is w. Cubed root of 64 is 4. Cubed root of z to the 6, divide the exponent by 3, and I get z squared. That's probably the hardest part. Now this one I might show that work. So then in the second bracket, we're going to square the first term. Then we're going to multiply them together. And then we're going to square the last term. Now you can kind of see why the exponent laws stuff came first. Okay, so then what would that look like? Well, this bracket would have a 3w and a 4z squared. And then my second bracket would be 9w squared, 12wz squared, and then 16z to the 4. Then, same, opposite, always positive. It's gross, it's weird, but it's a process that you can do, okay? Write these down in your formula sheet. Write an example. Put squared, multiply squared, put SOAP, or get really good at just following the formula. That's what I did when I first did it, and then I always hate having to refer to a formula sheet, so I came up with these acronyms so I wouldn't have to refer to it. I'm like, how can I get from here to here without having to look, right? And so I came up with SMS and SOAP. All right, last one. So for this one, not a difference of or sum of cubes, so I'm going to greatest common factor first. I can take out a 3a to be left with a cubed plus 8b cubed, which is now a sum of cubes. So I'm going to put the 3a, draw a bracket for a binomial, open a bracket for a trinomial. Cubed root of a cubed is a. Cubed root of 8 is 2. Cubed root of b cubed is b. Then I'm going to square. Then I'm going to multiply. And then I'm going to square. So 2 squared is 4, b squared is b squared. This one I didn't feel like I needed that step. Then I'm going to do the same sign, the opposite sign, and always positive. These won't come up that often, but they do come up, so practice these to feel confident in them, because when they do come up, you want to get them right. All right, good luck.